When you're testing things out physically, it's just way more limited by like the time it takes to actually do the testing. It's just way more overhead. It's like orders of magnitude more resources. Whereas, if you're simulating stuff, you can just have tons of computers running, doing it all much faster than you actually could.
How does Sim improve our software quality?
So at Queen's Autodrive, simulation is something that's fundamental to our software development process. Edge cases that we could never even approach in the real world, especially a dangerous situation where we should absolutely be testing it, but it's not something we can practically test our facility. I think the main thing that we appreciate at Autodrive is how quickly we can iterate on our designs using Sim. With MATLAB, we can test code that we've written 5 minutes ago without having to deploy it to the car. So when we go out to the track and we experience something that we didn't expect, it's valuable being able to bring that back to MATLAB and recreate it.
The high fidelity of MATLAB's simulation tools allows us to build a extremely high accuracy dynamics model for our vehicle, which allows us to test and be confident in our real results compared to our simulation results.
So we use MATLAB alongside Carla's platform for co-simulation. We work in perception simulation using a modeled environment in Unreal Engine. And then we use MATLAB's incredible physics engine for controller testing. This allows all of our team members to work in proper model-based design. So anytime we have an iteration of any of our model predictive control models, we can immediately test these in a very accurate sim instead of relying on working on the car. Any of our team members are able to push code on various different branches, and this means anyone from a general member to one of our director level teammates can work on any possible part of the system with instant results. So if a line of code is pushed, the package is immediately pulled in by GitHub Actions. We have an array of machines. We're deploying a bunch of GitHub Actions servers, and we are building every single package. After we build test, we are running on a dedicated simulation platform, a deterministic scenario. So we're running the exact same scenario for every single package and running pre-planned, here's a start destination, here's an end destination. We're getting metrics on every part of the way through that route. We can track any kind of results from whether it's classification accuracy, cross-track error for controllers. So we're looking at getting increased fidelity in our results, better models, better processes the entire way through. On the scalability side of things, we are running everything inside of Docker containers. They are pre-built images. In theory, we could deploy this to hundreds of instances or anything along those lines. Innovation side, what we're doing is we're running co-simulation with Carla and MATLAB. Well, MATLAB's tools are great for physics simulation and controller testing and low-level modeling. So Carla, running it in co-simulation, what this allows us to do is cameras and LiDAR sensors can be accurately modeled through Carla, whereas the physics engine in Carla is not keeping up for what we would want to do. So we're using MATLAB's physics engine alongside it as well.